In this video, I'm going to show you how to find the derivatives of exponential and logarithmic functions, including using logarithmic differentiation. So the first thing I'm going to show you, however, is the rules for the derivatives of exponential functions. So the derivative of a to the x, where a is a number, is a to the power of x times ln a. So ln is the natural log of a. It's kind of like saying taking the sine of a, except we're saying something like take the natural log of a. So ln stands for the natural logarithm. The derivative of e to the x is an easy one. It is e to the x, where e is equal to 2.718. And it doesn't repeat, it's non-repeating, just like pi. So we're going to use these rules to find the derivatives of these three functions here. So the derivative of y equals 7 to the x is going to use the first rule here. So a is our 7, so 7 to the x times the natural log of 7. Sometimes actually people, instead of saying natural log because it's so long, ln, people just sometimes call it ln as well. All right, so the second one, y prime is equal to, so same as before, we say 7 to the power of 2x, since we take the function as it is, and then we're going to multiply it by the natural log of the base. In this case, the base is 7. However, we also have to multiply and use the chain rule because we have an exponent here of 2x. So we need to also multiply this by 2. So we can't really simplify anything here, just to, but however, what I'm going to do is just rewrite it so that the 2 is in the front. So 2 times 7 to the power of 2x times the natural log of 7. All right, let's try one more. So y prime, when we're going to use the e to the x, so it's going to be itself, e to the power of 3x. And just like the other one where we had to apply the chain rule, I need to then again apply the chain rule to the 3x here. So then we have times 3. So we say that y prime is equal to 3 times e to the 3x. All right, so those are the derivatives of exponential functions. So now let's take a look at the derivatives of logarithmic functions. So the couple of rules that you need to know. So the derivative of log x with a base of b is 1 divided by x times the natural log of b, where x is greater than 0. And then the derivative of the natural logarithm of x is going to be 1 divided by x. And again here, x has to be greater than 0. Now the differentiation formulas for logarithms and exponents, they work together with the other rules that you've already learned. So whether you're doing implicit differentiation, chain rule, it all still applies. So let's take a look at a couple of examples here. So y is equal to the ln, or natural log of x squared plus 1. So we say y prime is equal to, so using this rule here, we're going to write this as 1 divided by our x value. So in this case, this will be 1 divided by, and our x value in this case is the x squared plus 1. So this will be x squared plus 1 in the denominator. And now we have to find the derivative of the inside. So we have two functions here. We have the natural log, and then we have the x squared plus 1. So we need to multiply this by 2x. So we're applying the chain rule here. So now we have y prime is equal to 2x divided by x squared plus 1. All right, let's take a look at the next one too. So y prime, this time we're going to use the first log rule. So this will be 1 divided by our x. So this will be 1 divided by 4x squared plus 1 times the natural log of the little b here, which is our base. So that will be times the natural log of 3. Okay, now we need to take the derivative of 4x squared plus 1. So that will be times 8x. So to simplify this more compactly, this will be 8x divided by 4x squared plus 1 times the natural log of 3. All right, so you can try the next one on your own. So what we're going to do now is we're going to move on to logarithmic differentiation. So you can use logarithmic differentiation to compute derivatives, which are difficult to compute in other ways. So what are these examples or functions that we're taking a look at? So let's say we want to differentiate y equals x to the power of x. Now the problem here is that we can't use the power rule because the exponent is x, is not a number, okay? So usually if this was, say, for example, x cubed, we would say the derivative y prime is equal to 3x squared. However, it's not a number, it's a variable as well. You can't use the rule that we just learned where the derivative of a to the x is equal to the a to the x times ln a, because again the base is x, is not a number. Okay, so an example of this would be the one where I gave you 7 to the power of x. So the derivative of this would be 7 to the x times ln 7. Okay, so what we need to do is I'm going to show you how to do logarithmic differentiation. But before I do that, we need to go over some log rules. The first one is the power rule. And this is where log with an a to the power of b. If it's a to the power of b, we can take that exponent and we can move it to the front. So this gives us b times log a. The next one is our multiplication rule. When we have two numbers that are multiplied, that is being logged, we can rewrite this as log a plus log b. And then finally, the division rule, a divided by b, if the two numbers are divided and being logged, we can rewrite this as log a minus log b. All right, some of you might not be familiar with these rules, but we'll practice them actually as we do these differentiation questions. So to use logarithmic differentiation, what we're going to do is we're going to take the natural log of both sides, and then we're going to use our log rules to do some simplifying. After that, we're going to use implicit differentiation to find our derivative. And then we're going to solve for dy dx, because that's what happens when we do implicit differentiation. And then what happens is, after we've done that, we're going to replace y with what we started with, which is what our question was at the beginning. So let me show you an example. So we have y equals x to the power of x. So what we're going to do, our first thing is we're going to take the natural log of both sides. So we have the natural log of y equals the natural log of x to the x. So what I'm going to do is I'm going to use that first power rule, and I'm going to take that exponent, that is my x here, which is the b, I'm going to move it to the front. So now I have the natural log of y equals x times the natural log of x. Okay. So now I can use my implicit differentiation, my step 2. Okay. So this was step 1. So my step 2. So the derivative of the natural log of y is 1 over y dy dx equal to, and we're now, because these are being multiplied, I'm going to use my product rule. So the derivative of x is 1. So if you want to show that, you can. So 1 times ln x, or natural log of x, plus x, and now I find the derivative of the natural log of x, which is 1 over x. Okay, so I'm going to isolate my dy dx by multiplying both sides by y. So now I have y times, I'm just going to call this now ln x plus 1. So x times 1 over x is 1. And now what I'm going to do is replace the y back with y equals x to the power of x. Okay. So this was my step 3. So dy dx is equal to x to the power of x times ln x plus 1. All right, let's take a look at one more here. So here we have y equals x to the sine x. So we're going to do something similar again. So first step, we're going to take natural log of both sides. We're we're going to move my sine x to the front using my power rule. So I have sine x times the natural log of x. Now I'm going to take the derivative. So we have 1 over y dy dx. Derivative of sine x is cos x times ln x plus sine x. Derivative of ln x is 1 over x. Move my y to the other side by multiplying. So now I have cos x times ln x plus sine x divided by x. And then finally, replace my y here with this expression back up here. So dy dx is equal to x to the power of sine x times cos x times ln x plus sine x divided by x. All right, I'm going to show you one more type of question. So sometimes I find that logarithmic differentiation is great to differentiate very complicated products and quotients. So we don't need to, but it is very useful. So if you take a look at this one here, we could use our product and our chain rule. However, I'm going to show you how to use logarithmic differentiation. So we take the natural log of y. Actually, I'm going to start this over here. So the natural log of y is equal to the natural log of all of this. All right, so now that I have this, what I'm going to do is I'm going to use my product and quotient rule for logs to separate all of this into separate logs, okay? So this would mean that I have the natural log of 3x minus 5 to the power of 4 plus the natural log of x squared plus 2x minus 3 to the power of 20. And then this is my quotient line, so this is being divided on the bottom, so I'm going to put minus the natural log of 4x minus 1 to the power of 7. Okay, I'm going to apply my product rule, or sorry, not my product rule, my power rule to bring all of my exponents, my 4, 20, and 7, and I'm going to bring that to the front. So this will be 4 times the natural log of 3x minus 5 plus 20 times the natural log of x squared plus 2x minus 3 minus 7 times the natural log of 4x minus 1. All right, so now I'm going to take the derivative at this point. So I have 1 over y dy dx is equal to 4, because it's just my coefficient. Remember, the derivative of ln is going to be 1 divided by 3x minus 5. But then I need to take and use the chain rule to take the derivative of 3x minus 5. So that's going to be times 3. Do the same thing with the other two as well. So 20 times 1 over x squared plus 2x minus 3. And this will be times 2x plus 2 minus 7 times 1 over 4x minus 1. It's very long, but quite easy to do. And then times 4. So my last step is to go dy dx is equal to, and I'm going to multiply both sides by y. And just to save a little bit of time in writing, when I multiply by y, I'm going to actually replace this expression here. So this will be 3x minus 5 to the power of 4, x squared plus 2x minus 3 to the power of 20, all over 4x minus 1 to the power of 7. And all of that is going to be multiplied by all of this, but I'm going to do some simplifying. So 4 times 3 is 12 over 3x minus 5 plus 20 times 2x plus 2, so 40x plus 40 divided by x squared plus 2x minus 3, and then minus 28 over 4x minus 1. It's very long. You don't have to do any simplifying, but we're going to actually stop here. And that's how you use logarithmic differentiation to differentiate complicated products and quotients.